to pick a different name. My name is better.
Yeah, this was running in 2006.
So I don't really yeah, that's right. So I came up with my row calculus in 2002, and I wrote it down in 2004 and published in 2005. And at that time, I knew that there was this other row calculus, and I didn't care. People can make their decisions as to what they call. So ours is capitalized differently because it's our row is stands is a acronym. It stands for reflective higher order, and it's not about adding rewrites to Lambda. I think it's it's an interesting thing to do, but it's not as fundamental as ours.
Anyway, those people must be interesting in the field also.
Sort of, kind of, yeah. Actually, I'm much more interested in seeing what's happening in Aarhus, because they're actually studying the row calculus now. Hans Hutel wrote to me, and there are two groups at Aarhus that are looking at type systems for the row calculus, which is pretty amazing.
Interesting.
Yeah, he wrote to me asking me some questions about names. Let's see if I can see. No, I don't see. I don't see. But I'll write to Hans and see if there's any any publications that they've done so far. Cool. We have a lot to talk about.
So, Greg,
yes.
Last hour was the RChain member meeting. What particular meeting is this one?
This is the community hangout.
RChain community.
No. So this is the RChain community hangout. This is the meeting I've been running every Wednesday at 11 o'clock for the last 3 years.
Thank you.
Yeah. So the purpose and function of this meeting is to allow the RChain community to have access to each other, in particular to any members of the leadership, and to make sure that everybody's working off the same page and that there's common understanding of common goals, and to touch base with each other and check in, learn about, because there's ultimately going to be specialization. So check in, learn about what each, subgroup is doing, what each sub effort is, where each sub effort is, and all of that. So it's it's our way of staying in touch with each other. It's also what I've found is if we conduct our communications, especially important work communications, which I'm hoping to do with Joe Denman in just a little bit, because we were having a really good discussion about the cost function. Joe has a lot of questions about how we justify the cost of input and output, which I think those are great questions, and we really ought to, as a community, have a common understanding of that. If we conduct that kind of work in person, in public, then it gives people a sense of confidence, that we're actually working on the stuff we said we were going to be working on. And B, it puts faces to names and names to faces, so people know exactly who's working on what, and who they should go and talk to if they have questions about a particular area of the work that we're doing. And finally, it's just we're a distributed community, so being in front of each other in this way, it helps build community. I think everybody knows that if you can rub shoulders with each other, then it has the potential, anyway, to create a sense of camaraderie and a sense of community. So that's the other function of this meeting.
In addition, I would like to say that I feel that this hangout of Greg is more about the actual development of RChain, and the previous meeting is more about side work. So how we cooperate in GitHub and things like that.
Cool. Let's get through all the updates. Ed held my feet to the fire. Thank you, Ed. And we got a summary of the financials out. We posted that yesterday in preparation for today's meeting. So I'll quickly run through that document just so that people can be aware of everything there. Where is it? Yes, here it is. Got it. Okay, so let me change the Zoom view and then go to screen share. Okay. So a lot of this information we have delivered to the community in the past, but it probably wasn't all in one place. So now there's a single document with this information, and we'll fold it into a more presented form than just a Google Docs in a bit. But because there was so many questions about it, we thought we'd go ahead and collect it. So first of all, there were 1 billion rocks minted, and people have wondered: is there going to be additional supply created? No. So short, simple answer. So if you want the contract address that's in the document, there it is. So we've also provided current distribution. So the co-op has about 88% of the rocks. The holdings have 10.3%, and the rest is the 1.7% is distributed either through has been distributed to date, either by paying contractors and other service providers with rock, or through the redemption process. You can look at the transactions here. So the largest wallet is the co-op multi-sig wallet, and then there's another co-op account, and then there's the RChain holdings, and then you can see a couple of spreadsheets for the breakdown of the distribution along with the graphic. And thanks to Ed for preparing those spreadsheets. So the other thing that people should have been interested in is whether or not any rocks will be burned. And so the short answer to that is yes. To be consistent with everything that we've said, process, we allocated 139,614,029 rocks for redemption. That number was calculated by the number of amps that were in circulation at December 12 of 2016. We redeemed 10,277,603 amps, which means that 129,336,426 are slotted to be burned, and they will be burned on the 15th of June, 2017. So hopefully that answers that question in as much detail as possible. And then people have been wondering how the AMP proceeds of rocks will be spent. So they will be primarily spent on development. So we are currently under contract with Pyrofex and CoinFund and other contractors, other service providers, those two being some of the largest contracts. And we're paying for that development with the proceeds from the redemption process. We're carefully and slowly divesting ourselves of the AMP, so we don't want to tank the AMP market, but we're doing that at a particular pace that is limited both by the technology and by making sure that we don't have an untoward effect or impact on the AMP market. So then what's the budgeting? So we have a very clear work breakdown structure. We've documented that with the community a couple of times. The link is here also in this document. So the vast majority of the spend is on development. Additionally, however, we do have a small marketing budget. So Patrick Maguire has been handling website, Twitter, Slack maintenance, and other things like that. Coin Interview has been handling our YouTube channels and also produced a nice a nice marketing video that was a reduction of a conversation that Ed and I had about the roadmap. Additionally, we're sort of getting many birds, a murder of crows killed with one stone. We're doing some work with CoinFund, specifically Alex Bulkin of CoinFund, to produce a tutorial on Rolang. And that tutorial is providing not just education to developers who want to be able to write and understand, maybe swap the order, understand and write Rolang contracts, but also that's driving out basically what our deliverable is in terms of running code for the next significant chunk of time. So the tutorial is about how you would write a contract that was a wallet, and how you would write a contract that provided a token, and then sort of the end-to-end execution of that, describing how all the pieces fit together to support that execution over a network of nodes. So that's what the tutorial provides, but that also is the end goal of our first major release, that all of that runs exactly as described in the tutorial. So it's both a spec for our developers and an education tool for the community. That's why it provides multi-purpose function. So what schedule? We haven't released a schedule. We have talked about the roadmap as in as detailed a fashion as possible. Again, please see the work breakdown structure that's linked here in this document. We have not, on purpose, we have not put the dates to the milestones. I have consistently said that that Homestead release happens 12 months post closing the funding with Auto, and I will hold to that. So it's when the funds from Auto are in the bank, the clock starts running. 12 months from that, guaranteed by hook or by crook, we deliver the Homestead style release. Now the reality is we haven't had any of that hold us back, and we've been doing quite a bit of development, and you can see it all in GitHub. And so, if there's any justice in the universe, you'll be able to have Homestead-like functionality much earlier than that. But my promise to the community is that. So we can talk about being aggressive. We can talk about being ambitious and all of that. My promise is 12 months from when the funding closes. That's when the Homestead release is available for people to play with. So that's the way I'm thinking about the schedule. If people want to think about it in other ways, we can talk about that. Additionally, people have asked whether there will be other native economic tokens than Rev. So let me parse that a little bit carefully. So ERC20 tokens on Ethereum are economic tokens, right? They can be utilized like Bitcoin or Ether in certain ways. So yes, Rolang and RChain will support lots and lots of economic tokens. Are ERC20-like tokens staking tokens? No, definitely not. So I think what's meant by this question, or one possible interpretation of this question, is will there be other staking tokens? And here the answer is we don't know. If it turns out that we have, we can argue that that's technically feasible, absolutely, we're going to do that. No question. If it turns out not to be technically feasible, well, the answer is short and simple: no. So the jury is still out on that one, but we want to be able to support multiple staking tokens. And we understand that there are lots of questions and concerns around that. For us, the most important questions are technical questions as to how that impacts the proof of stake mechanism. If it turns out that we can give a convincing argument that passes muster with both mathematically and with all reviewers and auditors of the idea, then absolutely we will provide multiple staking tokens. So hopefully that answers that question in as much detail as we can. So and then the final question that people have been asking is when the rocks might be listed on a major exchange. We have to be super, super careful about the status of rocks. We're not interested in them being a security. And so we have not been particularly aggressive about listing these on exchanges, because as soon as they are, that weakens our argument that this is not a security. We cannot prevent the community from driving to get it listed on an exchange. And if the co-op's membership pushes hard, or in the sense that they need something from the co-op, of course we won't stand in the way of having them listed. So really, getting them listed on an exchange is up to those people who are using rocks. If they want them listed, then talk to Poloniex, talk to whatever. But that's really out of our hands. We won't stand in the way, and if there's any information required from the co-op, we will certainly provide it. But it's not, we're not pursuing that. That should be done by the people who use rocks, or who are holding rocks. Again, for us, the most important thing is that rocks are the existing token to hold if you ultimately want to have compute power on RChain network. If you want to be able to run the row VM, in other words, you want to be able to get phlogiston to run row VM contracts, then holding rock is your best way to do that, because you will be able to convert them on a 1-for-1 exchange rate, or rev, or whatever the token may be called. And then rev can be converted according to the second half of the pricing schedule that Joseph and I were talking about, into what you can do to run the run contracts. So let me stop there and see if there's any questions from participants here in the call today about any of what's been said. And also check in and see if Ed wants to amplify anything that I've said or correct my misunderstandings.
No, it's all good. Greg, if you could just update the document to clarify that the exchange will be 1-for-1, and then also mention the word staking to clarify the native economic token. That would be helpful for others.
Okay, I will do that right now. Okay.
Awesome. Thanks.
If other people want to chat while I'm doing that, or if you want to kibitz on the language I'm putting in here, so I'm going to say, let's clarify, or let's distinguish. Let's distinguish between economic tokens, which are native to the chain, or to RChain.
I guess I had one other comment I wanted to make about additional native or staking tokens.
No, I want to be clear. You can be a native economic token and not be a staking token. So just to be super, super clear about this, an ERC20 token is native to Ethereum, right? You can't run an ERC20 token on the Bitcoin network. You can't run it anywhere other than the Ethereum network. So it is native to the Ethereum network. But can you change an ERC20 token for gas? No, you can't. Right. So likewise, there are native economic tokens on RChain, which are ERC20-like, in the sense that there is a standard definition of what a token is, a contract which specs out a token. and and that runs only on RChain, so it's native, but it's not staking. So sorry, I need to be super clear about that.
No, that's cool. Yeah, in Ethereum, the ERC20 contract was added just as another contract, afterwards. But in RChain, it'll be a system contract, we believe. It's more native than a typical ERC20 contract is.
Right. Well, a staking token will have the fact that it's staking will be lower level than just a system contract.
Got it. Yeah. So I wanted to just respond to one of the comments that was in Slack, that some people that bought rocks or exchanged amps for rocks as primarily as a speculative investment are really concerned about additional staking tokens being created. And I'll just say that we have two objectives on the co-op with it. One is to reduce the motivations to fork the code. And the second one is we really want broad adoption, which is going to help everyone. So
that's correct.
I don't think it's counter to, even those that are speculating on the value of rocks. It'll help everyone.
Yeah, I absolutely agree. I mean, the major problem here, as we've already seen, is the problem of distribution. How do you distribute the tokens across the community in a way that people don't grumble, that they feel like it was a fair process, right? And if you think about it, right, amps and Bitcoin are already well mixed and well distributed. People may not feel happy about the distribution, but people are by and large not taking it as an unfair process. And so if you could do a staking token that was linked to Ether, and another staking token that was linked to Bitcoin, then you automatically get a solution to the distribution problem. And now, in other words, that if you had essentially one for one, like, so imagine that you had an R Ether and an R Bitcoin. Sorry, an RF and an RBit. Okay, that works. So an RF is one for one for Ether and held in exactly the same distribution. And the RF is staking on RChain. Then suddenly you've got the distribution problem solved for a much broader population. And then what that means is that many more people are running contracts on the RChain network, which means people who are holding rocks and have the ability to run RChain tokens, suddenly they have a much more valuable commodity because they have the ability to run run contracts. So essentially, it's the rising tide lifts all boats kind of thing. So hopefully that helps people understand. And then in addition, we want to prevent this desire to fork the RChain code. So we have two basic mechanisms to prevent the forking. One is namespaces. So if you have a specific application in mind, then you can create your own separate namespace and tokens that are associated with that namespace that support the services you're offering and just utilize the rest of the RChain infrastructure. So the VM, the contracting language, the comms layer, the storage layer, all of that, you just get to use and special purpose the namespace just to support the services and applications you want to provide. So there's less of an interest in forking And then in addition, if it becomes possible to add in a staking token that's linked to those special purpose services, then that's even better, right? So there's less of an interest in a Doge coin and a Litecoin and all of that, because so much more of the stack is just, copied straight over. And you get all of the network effects, right? So that particular namespace is linked into all the other namespaces, and so you get Casper synchronization across those namespaces. You can have cross service contracts and the like, rather than being its own isolated, separate bubble. It would appear, at least to my reckoning, that's a much greater value proposition than all the work of doing the fork. So that's amplifying your comment, Ed.
I agree with everything you just said. I think some things that people worry about are if multiple economic staking tokens get introduced, then wouldn't that increase the total supply, and to what end? And then there's that whole problem set that goes with the total supply increasing.
Well, no. Again, what you really have is you would have exchanges, right? Because it's not necessarily the case that another staking token has the same rate of token to phlogiston. So, for example, you could have a token to phlogiston rate of Rev that's twice or three times or four times the token to phlogiston rate of RF or RBit. Right? So the total supply question is much more nuanced than people are talking about here.
Great. Yeah. Thank you.
Cool.
Greg, I'm going to back it up. I have a question about the type of contracts are we going to have in blockchain? I mean, you mentioned system contract and you mentioned, smart contracts, and then you said even these tokens would be even lower than smart contracts.
Right. So staking. It really depends on how much of Casper we can get up at the contract level. If we can get all of Casper up at the contract level, then we can have all of staking tokens at the contract level. The suspicion is that not all of Casper is going to be at the contract level, which means that it's quite likely that the staking tokens are going to live at the, because staking tokens and Casper are intertwined. They're connected. Right. Casper depends upon, what a stake is. Right. So it kind of has to know natively what staking. So like, I don't, I'm going to misappropriate some language. Vitalik was calling this idea of being able to have multiple staking tokens abstraction. And I want to make a distinction between full abstraction, where you can just, install a new staking token, versus some other kind of mechanism where you can't just install a staking token, where maybe you just have a few built-in staking tokens, and so you might start out with 3 staking tokens, and that's that, and then it would be either a soft fork or something that was related to a consensus about adding in a new staking token, right? So those kinds of things are still to be worked out and a part of this feasibility study.
Okay, thanks.
I could give an overview of what the community is doing for attempts for getting the rock on exchanges.
Oh, sweet. Yes, please do.
Then I have to share my screen. So
I'm going to stop screen sharing.
So So there's two exchanges called Eta Delta and Oasis. Everybody can list already orders there. And there's no thing of getting listed on these exchanges, so you can do it yourself. There's a few documents edited for Bittrex and decentralized BitSquare. And there probably we need some information from RChain. On Poloniex, the request is submitted by somebody. Lieke is not, it's in view, but not worked upon. And there are a few other requests submitted. So that's the overview at the moment.
I know the guys at Lika HJ, their Ethereum integration is going to be ready within the next 2 weeks.
Yeah, so, I heard it also.
Yeah.
And they are also, they are quite sympathetic to the RChain development. So it's no problem to get them. Yeah. So I go back. Let me go back. Well. So, did I share my screen, by the way? Or
I don't. Yeah. I actually don't see it. Can you go?
Well, let me get it. Okay. Well. Yeah, so this, can you see this or?
Yeah, you're good now.
Yeah, okay. So these are the exchanges that's been worked upon. I can post a link to in the chat box and then everybody can see it for themselves. Craig, you can share your screen again.
No, it's okay. I'm just crafting the language. If other people want to go for a bit, I just want to get this language nailed down.
Yeah, I have a quick question on the Rolang tutorial. I know it's just in the beginning, but will there be a comparison like you did with the blockchains from Solidity and Rolang? Clear comparisons?
Yeah, we'll do as best as we can. I mean, largely the focus is not comparative. The focus is explanatory. But we'll probably subsequent documentation will be to say something like, well, here's the standard token contract in Rolang. Here's an equivalent standard token contract in ER.
Great, perfect.
Yeah, but that's not the main focus of this tutorial. Maybe I'll just get this other language done after the meeting. So let's move on to some other updates here. Ed, do you want to talk a little bit about the trip to New York?
Sure. My voice is a little scratchy, so I'll be a bit brief, but the trip was awesome.
Your volume is way down. I don't know what's going on.
Okay, I don't know why. I'll try to speak up. But the trip was awesome. Let me this one. During the trip we had so many conversations, so many business cards exchanged, and then we had a couple of events in the evening as well. And I'm still following up. So Mike, thanks. You can hear me fine. So most people probably can. So we have follow-ups with some developers, both in terms of individual developers and teams that wanted to work with us. We're following up with a streaming music startup, identity related, and energy. We also had great conversation, Greg and Navneet and I, with Joe Lubin, and a couple of others from Consensus talking about RChain and how we can work together so that they can come up to speed a little bit more about RChain initially. And so we can also understand some of their requirements and make sure that RChain will support them ideally. Consensus is very much focused, or at least a big part of them are focused on the Enterprise Ethereum Alliance. So it's interesting to hear some of their concerns. For example, they were talking about long-running transactions, where you have a series of smart contracts working with each other, and then maybe you have an approval process, and the last step of the approval is not completed or rejected, and then the business transaction has to be rolled back. So that's not a problem. That's the same kind of thing that Greg built with BizTalk, and they're just normal smart contracts. But apparently, that's really hard to architect something like that on Ethereum. So those were great conversations. We had a couple investor conversations, both generally and a few specific with follow-up. So those were all great. On the organizational front, the RChain Holdings had their board meeting yesterday, and this was around the formal preparations to raise money. We need to file with the SEC for raising money, as well as the states in which we want to raise. So that's good. We decided Evan would be the general counsel of RChain Holdings, so that's great, and he's also the secretary as well. Another update, Shingai Thornton is still working on a Medium article introducing RChain that will be published on a CoinFund's blog, or at least promoted via CoinFund's channels, so that's great. Doing a fair bit of discussions, Navneet and myself and others, around wallets, identity, and secure messaging is kind of where, from a product perspective, we're giving a lot of discussion. So that's all I had. I wanted to keep it kind of short because of my voice. Any questions?
No, thank you. That was really good. I appreciate that. So then on to some updates on the technical front. So Kent has done some really nice work. I think, Kent, if I understood correctly, you've got the Hello World plus Cell 1, 2, and 3 compiling. Is that correct?
Yep, that is correct indeed.
That's awesome. If you feel, I know we didn't plan this, but if you feel like giving a little demo of that would be cool. And now we're moving on to making sure that we've got the little runtime adapter on the Rosette side, so you can start executing those contracts. So in particular, we're testing out the making sure all the tuple space code that I wrote is up to snuff, and then we have to put monadic adapters in front of that and in front of all the collections that we're going to be making available through the source-to-source compiler. And as soon as that's done, then you will be able to execute those contracts. So Kent and I yesterday were going through sort of what that means. It's a bit of a brain twist. It was for me when I built it. And I built this 3 times now in the past, so it's totally understandable. Because there are 2 different continuations to think about. There's the continuation that is the rest of the for comprehension, but there's also the continuation that is the code context in which that for comprehension is to be run, and so you have to keep track of both continuations, and you have to understand how the monadic facade on the tuple space links the 2 continuations together. And so that's kind of what we were going through yesterday, and we'll be going through probably for the next couple of days, and then we'll have people will be able to run the contracts that are compiling now. Kent, are you ready to give a little demo, or
Yeah,
do you want to?
I am. Indeed.
Awesome. I'll why don't you share your screen?
Cool.
And Kent, you're welcome to hook up with me anytime if you want to record more in-depth videos.
Yeah. Okay. So first up, we have cell 1 here, and that's the contract. All the cells do the same thing. You pass in a get, set, and a state channel, and then this is for retrieving. This is essentially like a getter method, and this is like a setter method. And so this essentially is the version where the get and the set are running in parallel. And so you can see the compiled version of the contract here. Essentially, the fact that it's in parallel is expressed to the block. And if you read I believe this was the Rolang spec paper, I might be wrong, but there's an explanation why you might not want to run this in parallel or you do want to run it in parallel, but you want to ensure to destroy the case that you don't use. And so here we have cell 2, in which we actually have a select case, which ensures that if you use the get, for example, then the set would be destroyed. So you won't have it, essentially you won't have garbage left around in memory. And so
in that case, the select kind of serializes the contract?
Yeah, so it essentially, if you actually look into the Rosette code, you can see how, actually it's more clear in the comments because it's kind of like a unformatted dump. But essentially, the select turns into a bunch of channels with a lock channel. And then so only the channel in which the lock fires true is the one that gets executed. And then after the one that gets executed, executes the continuation, then we have the lock false that gets fired. And so for every other sort of, case statement in the select, you'll have lock false being sent over. So it'll get destroyed. And then finally we have cell 3, which is essentially similar idea, but we're passing in one channel for both the for the requests. And so it takes care of both the get and the set at once. And so that's cell 3. Again, it's a bit hard to parse, but you can see the general idea here. Again, there's a flat map over the client. The request right here gets placed in, and then if the request is a get request, then continue with this proc. Otherwise, if it's a set, then continue with this proc, and then both the procs just do the contents inside here, which are the same, from cell 1, cell 2, and cell 3. So that's kind of a rushed overview, but yeah, hopefully people caught something out of that. I think, I might take up
that was very clear. I thought you gave a very clear explanation.
Oh, thank you.
The significance of the cell contracts is those are proto wallets. So think of the cell as holding values, right? And so what you want to do is you want to be able to read the current value in the wallet, right? And update the current value in the wallet. So the cells are kind of our very initial wallets. And so this work feeds into the work that will go into the tutorial at the end of the month. That's why we're kind of focusing on those contracts first of all the contracts we could be using as our Hello World examples to test the compiler. So that was very good. But it also links then into the work that Joseph and I have been going over, and it's actually a very interesting conversation. I think I'm going to switch over to.
I'd be happy to provide a bit of an introduction as to where my thinking is.
Yes, please do. I'm just trying to find the document.
I can screen share in a second. First, Kent, would you?
Yep.
With the code that you've compiled there into Rosette, can you do a code dump on the Rosette code that you've produced really quick?
Yeah. They're all on the Slack. They're all on #Golang.
But I mean, just like for sake of this demonstration, if you can't, that's fine. But it would benefit.
I'm a bit confused what you're asking because.
I mean the byte.
To do the code dump of the file of the byte code.
Oh, in Rosette.
Yeah.
Oh, so the produce function here, this still is missing a few methods. So
sure.
It's not actually going to, be able to generate the full bytecode, if that makes sense.
Sure. Well, that's fine. I'll just go ahead and screen share if you want to stop then.
Yeah. Okay.
Cool. So there's a conversation that Greg and I have been having over how we want to define the cost equivalences, and my interpretation has been since we started that we want to evaluate resource consumption on a very, very low level, and we want that to be parametric in how people want to define what their resources are worth. So how much memory and storage you have, and how fast your CPU goes. So again, this is just my interpretation. Greg and I have our views are slightly competing at this point, but I'll just run through what I have, and it's essentially that we have bytecode, and we have our arguments or our operands for the bytecode, and then we can form those into a sequence as we typically would. So the bytecode would look if, like what Kent just showed us, if he did a code dump and could show us all the bytecodes of the contract that he had just produced, that would essentially give us what we'd want to analyze. And we want to evaluate that bytecode based on, again, the size of the operation or of the operands, and based on the time it takes to execute an instruction. So essentially, here we want to evaluate based on the cost. G is a cost function based on the cost of the size of our bytecode instruction and the time it takes to evaluate it. So the cost of the space it takes up plus the cost of the time it takes to execute, and that's going to give us the cost that the actual instruction is going to be. With our operands, we want to evaluate those based on how much space they take up, because essentially any instruction, at least in modern architectures right now, any bytecode instructions are going to manipulate memory in some way. Obviously, we're going to extend those to include a storage layer so that our bytecode instructions are on the level of the blockchain as well. But essentially, then we want to evaluate the size of all of our operands, and we want to multiply that times the cost of a word, which is our smallest unit of memory. So this is the size of all of our operands and the cost of those. And this is the time it takes to execute an instruction and the cost of that. So then we can extend that if we have a sequence to just kind of iterate over that and take the sum of the cost of all of our bytecodes. And this is really, really cool because then we have like an actual resource appraisal that's an appraisal of resource uses that exists on a very, very, very low level. And ultimately, this is again going to be performed at compile time. And Greg, if you want, has been a proponent of a higher level definition, which again I'm not against, but I'll let you explain your side if you want, Greg.
Yeah. No, this is a really good conversation. So the way I want to view it is not that the Rosette VM is where the rubber meets the road.
Yep.
So in particular, the aim is that ultimately we get rid of in a step-by-step fashion. First, we want to jettison the JVM. We don't want to be tied to the JVM for lots and lots of reasons. We utilize it as a stepping stone initially because it accelerates our development and also gets us reach onto lots and lots of platforms and bindings to lots and lots of languages. However, once we have presence in each of those communities and people are successfully running contracts, those contracts execute against our VM and we can get rid of the JVM and just have our stack as long as we can take the Rosette VM to native. And then over time, we want to rip out the Rosette VM and go directly from row VM, from row VM to native. Now, lest that seem terrifically ambitious, as I've mentioned before, in 2003 with Jan Gray, who is a very accomplished person in this area, and Satnam Singh, who I hired away from Xilinx. He was the chief architect for Xilinx, into Microsoft, into my group. And with Alan Brown, who was also one of the highest level technical people in Microsoft. The four of us wrote for a Think Week paper for Bill, a description of an architecture that we built, which compiled pi calculus directly to FPGA. So that was in 2003. So 14 years ago, we had an architecture for reducing pi-like calculi, including the row calculus, directly to hardware. And so we can imagine that over time, if we are successful, that we have a mechanism whereby the row VM itself is what's native. And so if we want our cost function architecture to be robust against those evolutionary changes, we want the cost function to be expressed entirely in terms of the input-output operations. So the for comprehension and the output. So let me just do a quick screen share here. There we go. Okay, so if you look in this document here, which Joe and I are currently working on together, I will get a shareable link which people can view. I don't want any comments just yet because we're still working this out. And then just paste this into the chat. You can follow along, or you can follow along with the screen share. Okay. So if you look here, the shape of much of the costing comes from the core transition rule of the row VM. So the core transition rule of the row VM in its simplest form is when you have a for comprehension, actually this is, now it used to not matter, but now conventionally I write it in this order to match with beta reduction in the lambda calculus. Okay. So when you have a for comprehension waiting at X for some input Y, and then having received it, it will run P, in which the input it's received is bound to Y. And when that's running in parallel with outputting the payload Q on the channel X, then this evaluates to P running with the payload Q bound for Y. Right? So that's the most basic form of the transition rule. Oh, and this is, sorry, it should be that. That's the most basic form of the transition rule for the row VM. And so our cost functions should reflect that. Now, in our case, what we're saying is that the cost function, the type of the cost function is very specific. So people should understand that. So the type of the cost function takes a row-lang program unadorned with cost and produces a row-lang program adorned with cost, right? So that's the type. So it takes a program and produces a new program together with the cost. And presumably that new program is the same as the old. So in general, what we expect is that the cost function should recurse, right? So if you want to calculate the cost of the for comprehension, first go and calculate the cost of the remainder of the program. Having gotten that, then tack on the cost of this initial synchronization chunk here, synchronization and binding chunk. So that's what we do. We say, well, I'm going to go ahead and let the cost of the rest of the program, i.e. P, I'm going to calculate that using so again, the notation here is the cost function is the vertical bars. So we calculate the rest of the cost, and then we decompose that, because remember, it's going to return us a program, and it's going to return us the cost annotation. That's R. Okay, and we're going to need this program in calculating our pair. So what we're going to return is a pair. So it's the program, which is just this program all over again, but whatever the costing function did for P, that's what we're recording here. There's no dot there. So that's the first part of the tuple. And then the second part of the tuple should be the cost, right? And in our case, the cost is going to be a vector. Well, that's weird. That's very strange. It should be a vector right there. And that cost is going to be the cost of the channel access times the data, the max on the data that you're getting, and then 0 in these other dimensions. So our dimensions are access to memory, access to storage, access to network, and then any computational cycles. So those are the 4 different components of the vector. So phlogiston is not, I repeat, phlogiston is not a single number. And to compare with the Ethereum calculation, gas is a number. It's a scalar quantity. For us, phlogiston is a vector. And then the reduction, the mapping from rev to this vector is like taking the magnitude of the vector, something like that. You can think of it along those lines, and it's not too far off. So we're going to add in the cost of the remainder of the program to the cost of the channel access. And now to link what Joe was talking about to this formulation, we can go back up here into the document. And now what we're saying is that the cost of the channel access is given specifically. So the cost of the channel access is the cost. So we can now derive it per realization of the channel access mechanism. So one realization of the channel access mechanism goes from row-lang to rosette to the JVM, right? And under that, the cost is going to be whatever the cost of the implementation of the consume method is, where here, the consume we're talking about is this one right here. Let me go do So it's this method right here, right? And so when we take the cost of invoking that, what we're really saying is, give me the cost of the Rosette bytecodes. And then if we want to factor in that cost relative to the JVM, we can factor that in. So that's what this number here is. And then what we would do for, and that's why Joe was asking about the code dump. So here, this would be to link this finally all together. So to get this linked up to this, right? This becomes go and calculate the bytecode, which is what this does. So this would be this gives you the code object. When you say compile of this request expression, that gives you the code object, and then we take the cost of that, and that cost is the G calculation that Joe was doing up here.
Yeah. So essentially, the result of this is plugged into and becomes B in this function.
Exactly right. That's well. The GP of B is this is just another notation for that.
Yeah. Exactly.
Yeah, exactly. So they're complementary points of view, but the important thing I want to stress is that it may be that you have a different way of doing channel access than going through the tuple space implementation that maps to Rosette, which then maps on to Scala and then to the JVM. Right? You might have something that's more direct. It goes from Rolang directly to the metal.
Exactly. Yeah.
Or it goes from Rolang, not through some compilation procedure to an Intel architecture, or it goes from Rolang to a high calculus specific kind of machine. So in which case, this calculation here is going to be different. So these become parameters to the costing, and what Joe is specking out here is how you justify the parameterization for our existing architecture.
Well, and I guess Greg, to pick up on our conversation where we left off, is that regardless of our implementation of how we realize it, whether it's bytecode or not, this term is. I mean, it takes, I guess, a bytecode instruction as an argument, but how I'd imagined it evolving is a bytecode instruction per CPU cycles that it requires to actually execute it.
I hear you. I think that they're very complementary. So, and as I understood your desideratum, right, what you're really trying to do is to provide justification both to the market and to our community on what we give here.
Yeah, like
I totally agree with that. Yeah,
we actually derive our costs like at the basic level, how we calculate those. Yeah,
exactly.
And then from here, the plan is to do exactly as you're outlining and specify the language items in respect to this. But so yeah.
Yeah, cool. No, I think we're very very much on the same page. Yeah. I just what I was arguing was we're not wrong if we simply give a number for this, right? If you bake into this, so again, it would be per namespace, right? When X is a memory access, you give one number. When X is a storage access, you give a different number. And then you can go back and you could say, well, we justify that number by this calculation, right? But the numbers are parametric per namespace. And then you can like when the market changes or when our implementation changes, we can give different numbers and then we can justify the numbers, but we can cut off the cost calculation. In other words, there's the cost calculation factors into two calculations. One is the cost of channel access, and the other is how you justify that channel access cost.
So, Greg, you may have started to answer this question, but how would costing of foreign function invocation happen? For example, there'll be a lot of encryption and decryption and signing and going on, which are expensive operations, but most likely foreign operations, right?
That's exactly right. And so in that case, and this I was developing this language with Joe previously. So there are going to be things that are primitive to Lang, but non-primitive to Rosette and non-primitive to the JVM, right? And so that's where Joe's framework really begins to shine, because we need to do for example, calling the SHA-256 calculation, or whichever elliptic curve thing we want to call, that we're going to cost out in terms of the cost on the implementation platform, right? And that's where Joe's calculation comes into play. So we compile 2 byte. So for example, Rosette doesn't have any notion of those operations, right? That's going to be primitive imported through Java into Scala into the Rosette clean room implementation. So the Rosette part of the compilation is just the cost of doing a function invocation, right? And then the Scala implementation provides no additional information, but the Java implementation provides the additional information. And so we accumulate all of that information as a part of the bytecode summation, right? So whatever the Java bytecodes are, that is a part of the justification of the cost that we give to that computation. Does that make sense?
Yeah, and that's when you have a Rolang function that maps down to, what if it's a private namespace and it's using a foreign function that was not anticipated.
So again, they, as a part of the private namespace, use characteristic, right? The profile of that private namespace, they have to provide that costing.
Got it. Okay, cool.
Yeah. And the nice thing then is, well, you're in that namespace, so using things in that namespace means that you trust that their cost, or you've consented to their cost. And you've consented that their implementations are trustworthy, right? And yeah, so that's the to me that seems like the right kind of factorization. Wow, it's already 12:09. I didn't realize that we were so far over. Are there any other burning questions, updates that we need to get done? Because I really have to jump over to other meetings.
Well, great work, especially Joe and Kent. Awesome progress.
Yeah, this is really cool. Yep. Cool. Well, I'll see you guys next week.
Take care, everyone.